Okay, so for question 6, it says find the, well, we're given two planes or equations of planes, pi 1 and pi 2. It says find the Cartesian equation of another plane, pi 3, which is perpendicular to these two and passes through the point 0, 0, 0. Okay, to find the equation of a plane, well, my preferred method, if you can use this, is the or dot n equals a dot n. To use this method, you need a point that's on the plane. We have that. This is our point. And we need the normal. So we need a normal vector to the plane. We don't have that yet, but we have two other planes, and it says our third plane is perpendicular to both of these. Now, if it is perpendicular to both of these planes, what we can do is we can say that the cross product of the normals of these two planes, we can use that as the normal for this plane. And I'll explain that in a little bit more detail here. So, firstly, the normal to pi 1, well, a normal, is 3, 2, 1. It's the coefficients of x, y, and z when it's in this form. That's because of this formula. Again, I'll show you that in a second. So the coefficients of this are 1, -2, 1. So, sorry, not the dot product, the cross product. So when I find the cross product of two vectors, what I get, by definition, is another vector that is perpendicular to both of these. So I'm going to get a vector here that is perpendicular to this and perpendicular to this. And because this is the normal of plane 1 and this is the normal of plane 2, then this will be perpendicular to both of these planes. Hence, it is the normal to the third plane. Okay, hope that makes sense. So to get the cross product, this is in the formula booklet, guys, and if you need further assistance, check out my lesson on this topic. But it's 2 times 1 minus 2 times 1. Then we have 1 times 1 minus 3, this times this minus this times this. And finally, 3 times minus 2, this times this minus this times this, which is minus 2. And this equals 2 plus 2 is 4, 1 minus 3 is minus 2, minus 6 minus 2 is minus 8. And that is a normal to our plane 3. Now, once I have this, I can say, you could write this as well, by the way, guys, as 2 times 2 minus 1 minus 4, and then just use this as the normal. Either way is fine. So I can say or dot n. Now or is, I like to think of it as x, y, z. Well, it is x, y, z. Dot n, the normal. You can use this or this. You can simplify it at the end again if you want anyway. 2 minus 1 minus 4. I'm going to use that because it's easier. This dot this equals a dot n, which would be, by the way, it's technically, it's not a point, it's a position vector. I should have made that clear. Position vector. So this would be 0, 0, 0. Well, I'll write it in, but it's just going to be 0, 0, 0, 0 dot n, which is again 2 minus 1 minus 4. But either way, this side is just going to be 0. And now I get 2x minus y minus 4z equals 0. And that's the equation of the plane. If I used this, I would have just got 4x minus 2y minus 8z equals 0, which is fine. That's the exact same plane. You could have then divided by 2. All the same thing anyway. Okay, finally, part B. He says find the coordinates of the point where pi 1, pi 2, and pi 3 intersect. If this was a paper 1, yeah, this is not an easy question, but it's not. It's a paper 2. So it's actually a very easy question. All you got to do is do menu, algebra, solve system of linear equations, 3 of these, x, y, z, and then you just type in the equations 3x plus 2y plus z equals 6. x minus 2y plus z equals 4. And then my final equation is 2x minus y minus 4z equals 0. And I just have to write in the point, 41 over 21 minus 10 over 21 and 23 over 21. So that's 41 over 21 minus 10 over 21. And what was the final one? 23 over 21. 23 over 21. It's a point, so we write it in point form, not in vector form. Okay, that's question 6.